Hello everyone, this is KP the Math G here. I hope I don't get too much of an interference, but if I do, it's alright. Just have something going on next door, so bear with me, okay? This is a 2025 free response question number 2, and I chose 2 because it is one where your calculator is required. So let's take a look at this. Instead of going over everything that this thing says, it just says find the area of R. Okay, now notice here, I don't know whether I drew this exactly right or not, but this appears to be the graph of g at x, the top one. Okay, the bottom one down here, I should have done it in a different color, sorry about that, but this is the function f. F at x is x squared minus 2x. So the top function is g, the bottom function is f. The region in here is R. So what we're going to do is we're going to find the area of this region. Now, and you could do a subinterval. I'm just going to do it right here, maybe like this. Okay. Okay, I don't know if you can see that or not. Okay. But there you go, there's your I subinterval right there. And that's, alright, so always, let's just look at it this way. This is your top one. It touches the top and it touches the bottom. Always when you have two functions, I don't care where they are. If you're just finding the area, all you got to do is, you just got to remember, where's it going from? Well, it's going from 0 to all the way to 3, it appears. So from 0 to 3, okay, and yeah, this is region R, all of this, all the way to 3. Okay, from 0 to 3, and then now we just got to determine, now this is G up here, and this is F down here, so G at X minus F at X, and it wouldn't hurt if you just put it in parentheses like that, put a little dx there on the end, right there. Okay, that'll work right there. It's always the top one, the higher one, minus the bottom one. It doesn't matter where it is, and it does say just find the area. Okay, so we've got to find the area. We don't just set this up. Now, you excuse me, I got some kind of phone call here. Bear with me, I didn't know this was coming. I always get these right in the middle of a video, right? I mean, alright, so if they want to, if I don't recognize the number and the name doesn't appear, I don't answer it. So that's why I do let it ring, okay? I don't know if they left me an email or not or anything, but okay, it's quite all right. Okay. Well, this is my wife's number. Okay, never mind, my wife's phone. Hold on just a second. I'll bring the phone to her and let her. This is your phone. Yeah. That's my wife's cell phone. Okay, not mine. She left her phone here. Okay, now we'll get started. Anytime you have a problem, and I already mentioned this, the top minus, always minus, never plus in this case, the top minus the bottom. You're just finding the area. If you label G at X as this and F at X as this, you can get away was doing this right here. Now, I want to show you, you have to, I'm going to clear everything, you have to hit y equals. I already have this in my computer. I've got a y sub 0 and a y sub 1. I have no idea if you can see that or not. Maybe, maybe not. And if you can, you may not can see it very plainly. But I have a y sub 0 and a y sub 1. Okay? So my y sub 0, I'm going to put it over here. My y sub 0 is equal to, now I just you hit y equals right there. I've got a y equals, and then you have this string of y0, y1, y2, y3, y4. Some calculators have like a y, starts at y1, y2, y3, y4. Or which one yours does, just go with that. My top one is y sub 0, okay? And y sub 0 is this. So I'm just simply going to put x plus sine of pi x. Okay. And that's exactly what that is right there. Making sure you copy it down right. Y sub 1 down here is x squared minus x squared. Sorry about that. X squared minus 2x. I do believe that's correct. So if you have y1, put that in y1, put this in y2. But either way, I'm going with y sub 0 because that's what my calculator does. My calculator is on my phone. Okay, I downloaded it. All right, so there it is. You put those in there. Now what you can do is you can put that in. I've got them in there, and then I hit second and quit, so I get out of it. Now to figure this out, I can go back. I have a math. All right, on mine I have math. I'm just can only go by what mine is, and some of you already have the integrating sign on it. I don't. I can just hit FNINT. Okay, that is what I'm doing, and mine does show up like this. Okay, so I have up here an integrating symbol like this, and I have a box here and a box up here, and I have a box here, and then I have D and a box, but the X is in the box there. Alright, so all I'm doing here is I'm putting from 0 to 3. Alright, like that. You can put that in there, and then what you do is you can, okay, so since I know that this is G minus F, and G is y sub 0 and F is y sub 1, I can put y sub 0 minus y sub 1 dx like that. Okay, so to do that, now I'm just going to go ahead and put 0 in here to 3. Okay, and then I can put now I can, you want to get into y bar, so every which way you have to go to get into y bar, I can do alpha and y bar on mine. So there it is like this. So you'll see up here y0, y1, y2, y3, y4. I wish I could just put mine up and you could see it, but I don't have that luxury. Alright, I'm going to click on, well, first of all, I need a parenthesis, so let me get out of this. Okay, so y sub 0, I need a parenthesis right here, so I'm going to do that. You start off with a parenthesis. Now I want to get past this y sub 0 right here, if I can do it. Let's see if I can. Oh, I had it. There it is. now minus sign. Now I go back to y bar again. Alright, and then y1, close the parentheses. Alright, delta x. Now I'm going to hit enter, and I should get 5.136. Okay, you can leave it as 5.136. So 5.136. I'm going to round up. You in calculus, you got to go 3 digits past the decimal. Okay, if it's 6 and it rounds up to 7, it does. You can do that, or you can just leave it at 6 and drop off all the rest of the numbers. And if you go more, that's fine. You just can't do 5.14 or 5.1 or even 5. You got to come out to 3. And I don't know if it asks for units. There's no units there. Just find the area, and that's it right there. It'd be something like square, if it's area, square, whatever units that is. Okay, so there is part A. That's it. Okay, and I remember that being so right there. Okay, let's look at part B. Alright, now let's see that. I'm going to erase this part right here. Alright, let's see what this thing says. And you do need a little practice with your calculator, knowing how to use that calculator properly, and basically that's what this lesson is all about, is getting you familiar with that calculator like that. Okay, so let's go ahead and look at part B. Alright. Alright, so you know, I have limited room, so I just have to erase and write down the next problem. Okay, so B is, what does it say? Region R is the base of a solid. Alright, region R is the base. Alright, I'm just going base of this solid. Alright, got you. For this solid, at each x, the cross section perpendicular to the x-axis is a rectangle with height x, okay, and it is a rectangle. Alright, so length times width, so base times height. Alright, right there, base times height. I can just do it like that. Base times height, there we go. Well, we know what the height is, it's x. Now, okay, so let's see what we got here. It says, let's see, the cross section perpendicular to the x-axis is a rectangle with height x and the base in region R. Find the volume of solid. Okay, so it says cross section. So when I see the word cross section, I'm just going to put down keywords, cross section. Alright. Now cross section, that's going to be, it has something coming out, you know, like a rectangular, you know, so it comes out. I can't draw it in 3D form, so I'm just going to let it be. But I do know what the base is. I know what the height is. The height is x. And I know what the base is. Well, it's what we just did a while ago in part A. It is the base. The base is, well, in this case, g at x. G at x minus f at x. Always remember that. If you have more than one, okay, function like this, just like we found the area, okay, so g minus f, just a while ago. So it's g minus f, and then that times x. So again, we are going from 0 to 3 again, okay, and it's going to be, you can put the x in front, does not matter, but g minus f, and there's that, and then dx. That's your thickness. There's your volume right there. Okay, this is the area right here times the thickness. Okay, that's what that is. Alright, so that's what we're talking about here. Your area here times your thickness. Alright, so that is what we're talking about. Now, of course, on my calculator though, I have it from 0 to 3. I've got to erase this because I don't have room. I'm still doing this from 0 to 3. And in this case, I'll remember that y sub 0 is g, and then f at 0, f at y sub 1 is f. Now put the x on the end, and then dx there. And that should do it. I mean, at least now you just got to find it. And again, let's see. I covered up my calculator. Alright, so let's do it again. Alright, so I need to go back to math and back to the definite integral. Now, let's see here. I still need to go from 0 to 3. Put that in there, and then I need to put in right here. Now you can do either way if you want to. Y2, again, get back to y var. That's the key to understanding this problem. Get back to y var minus. Alright, go back to y bar again to put in the other one, y1. Close that. Now remember, that's times x. And then, now, enter. Okay, now 7.704, 7.705, okay. And that works out just fine. 7.705. And make sure they can see that decimal there. Okay. Again, go out three numbers past the decimal, tenths, hundredths, thousandths. If you go out further, that's okay. Just don't go out less unless they say do so. If they say round to the nearest whole number, then sometimes that happens. But if it's anything, it's going to be round to the nearest whole number. This would be 8.0 or just 8 really. But you cannot do that here. Okay. So there is B part right there. Okay, now let's see. Let's go ahead and do C part, and I'll leave D part for later. Maybe we have time for all four. I'm not sure. But it says, write but do not evaluate an expression. Alright, let me erase this now. Okay, let's do C part. Alright, now, just keep in mind that on the B part, I know I can't show you every last little jot and tittle here, because if I do, I won't have enough room to work this. I can turn the board over and work, but I know it's just so much easier to just leave so I can see the graph, what's going on right here. Alright, so right here, this one here, I need this erased so I can deal with this. Alright, so right here now, I'm going to say, look right there, that's what we're going to need there. Alright, so let's see, it says write but do not evaluate an integral expression for the volume of solid generated. Alright, so it's an integral expression. Well, I already know that this is an integral expression, and now it is a volume of solid. It is rotated. It is a volume of solid, and it's rotated. Now, when I see the word rotated, I'm looking for pi r squared, or I'm looking for pi big R squared minus little r squared, and this is if I have a hole here, and this is if I don't, no hole right here. Alright, and I hope maybe by now, if you haven't been taught that, I'm teaching you this now. Okay, I don't know if you've been taught that just yet, especially for those this year who are taking the course, the AP Calculus course. I'm just going to show you where the difference is, hole or no hole. You have a hole in this particular problem. So let me just say this. It is going to be something pi r squared. It's going to rotate into a circular, it's going to make a circle around this line, y equals -2. The horizontal line, y equals -2. Okay, so it's a volume of solid. We know it's rotated automatically, pi r squared, if it's no hole. But there is a hole in this particular case. I'm going to show you how I determined that there is a hole. Graph is here. No graph is below here. The hole, okay, so I wish I could show you better. My graph is too far down really. But if we were to do something like this, there is a hole right here. Okay, so from here, okay, like this. I can't go any further down, but this is a circle here, and then this one here is a circle as well. I can't even go all the way around with that. And this is the solid part. This is the solid part. And this part in here is the hole. Alright, so here's how it's done when you have two equations right here. Remember, G's on top and F's on bottom, so I need to realize that. And I am always start with pi. I am still going from 0 to 3. Okay, now the R is right here. Now I just need to realize how far that is. Okay, so that is going to be, it's always going to be this still. It's just going to be like this. G at x minus f at x. That's the solid part of it. Now minus, and then it's always minus. In this case, it's minus. It's going to be minus. Okay, square. Don't forget to square it. And then now minus this part right here. Okay, so let's see. Let me think just a little bit. I think I've got it. Let's see. Minus -2. Yeah. Right here. Minus -2, like that. Now all of this is squared. Okay. It's this minus -2, which is really just plus 2. Alright, minus negative is plus. Alright, and then let me think just for a little bit. Wait. Yeah, I'm sorry. I'm so sorry. It is the top portion. I'm sorry. The top. Alright, minus -2. That's better. Okay. I've been away from this for a little bit. Now minus negative is plus. Always the top portion first. Alright. Now always subtract it off. And then the bottom portion is f at x. F at x minus -2. So that's just the way it is. And always remember, put it all in quantity squared. Okay? Quantity, the whole thing is squared. Minus -2. Okay, like that. Okay? And that's just the way it is. When you have 2, I don't care where you put your absolute interval at, it's always going to be the top portion. This is the bottom. Okay? Minus -2. Minus -2. Minus -2. Now, we're not figuring, so we don't need to put the y sub 0 and y sub 1. We don't have to do that. Okay? If you want to put down at the beginning, though, g at x is y sub 0 and f at x is equal to y sub 1, you can do that on the, and let them know, the graders know, those who grade your paper, they'll know now that that's what you're doing. Okay, so minus a negative. If you just leave it as plus right here, that's fine. Alright, now there, that's so much better now. And dx, okay. So really, it is this. Let's just box that in, and then finish the box in, and now dx at the end right there like that. Alright, there it is. Okay, now that's how you do that. That's just something, sometimes it would take too long to really explain everything in detail with this one. Just know that when you have 2 functions like this, you don't always have that, but if you do, it's still going to be the top one, okay, and then the whole length of that minus -2, which is plus 2. This whole length here from here to here, and then 2, okay, minus -2, always going to be a minus sign, but it makes it plus, which is really good because you are adding that to that. And then this portion right down here, okay, that right there, minus, okay, and then the f at x minus -2. Okay, and there that is. That one was a little bit, I had to go back over, but always remember it's pi, the big R squared minus the little r squared. And I tell you, I even had to go back a little bit and study it a little bit myself to make sure I understood what I was looking at here. Not always is easy to explain, but at least I hope you get the idea. It's going to be the larger height, the highest one, okay, which is g minus -2, and then the lower one, f, minus -2, just like that. Alright, there it is. Okay, so that's all I have for this video. We will do probably section D is dealing with the derivatives. So we did everything that involved integration, and then the next problem we'll do derivatives, but that's what you're doing. And just remember, it's so much easier to be able to recall something from your calculator if you can store it right up here from the very start. But make sure you put your y sub 0, the top one in y sub 0 and the bottom one in y sub 1, or y sub 1 first and then y sub 2 second, whatever you do there. Okay, so that would be that there. So that's the idea behind this. I just wanted to show you how to put it into your calculator and what to expect. Let's say, like when you got to this C part here, it is a volume of revolution about an axis. That's what you would do here, especially if you have 2 functions like this. Okay, anyway, that's all I have for right now. This is KP the Math G, getting ready to sign off. If you haven't subscribed, please subscribe if you like to. If you like to make check off that like button there, or just you can click on the like button. And of course, I always smile when I say that. I just say that every time I do a video. If you've watched me before, you've heard me say this every single time. So anyway, it's not really about me, but if you like to make a comment, please make a comment. And then again, if you don't want to do any of that, again, this is for your benefit and not mine. It's for your glory and not mine. All it does to this 65-year-old man is keep his mind sharp. So hopefully, if I do get dementia, I'll be 105 years old or something like that. By that time, I won't worry about it. No, I don't know if I'll live 100, but it'd be nice if I did. But if I am, I want to be in my best faculties up here. Able to walk, able to move my arms and everything, and do things that I can do. Maybe even drive still. I don't know, but I'm not worried about that for another few years, quite a few years. So I'm just blessed to be alive now, alive and well, and doing as well as I am, and still thinking about this kind of stuff here for you. All right, KP the Math G signing off. Ladies and gentlemen, have a great day.